Hi everyone, we are Team Remember to Lock, which consists of me, Shenjia, Andrew, and Kunshen. And our topic is on optimistic locking. So just an overview of the whole project, we will be going through introduction, optimistic versus pessimistic locking, how does optimistic locking work, how databases support optimistic locking, demo, requirements, benefits, and last but not least, limitations. So what exactly is optimistic locking? Optimistic locking is a technique for SQL database applications that does not hold row locks between selecting and updating or deleting a row to ensure data integrity. In fact, despite its name, this is achieved without resorting to any locks. As seen from the diagram, optimistic locking relies on checks that are made against the existing data on the data store by transactions during update time. Every time a transaction is trying to make an update to the order, it will check if it had changed before proceeding. As mentioned earlier, there are no locks present. Pessimistic locking, on the other hand, is when you lock the record for your exclusive use until you have finished with it. It has much better integrity than optimistic locking, but requires you to be careful with your application design to avoid deadlocks. This is exactly what we have learned in AA class, where transaction 1 holds an exclusive lock over the order, while transaction 2 has to wait for transaction 1 to finish committing first. Now I'll pass it on to Kunshen to continue.
Okay, thank you, Sharon. So how does optimistic locking work? Optimistic locking is not a database feature, but a practice that is applied using the database. For example, a strategy can be applied where a version number is taken note of when a record is read. And other methods involve keeping track of timestamps or the record's column values at the point when the record was read pending its modifications. So when the record has to be updated, the record's version number at that moment of time is compared against the version number that was read. And if it is different, it would have meant that another user have updated the record between the time when the record was first read to the point of time when it needs to be updated. With optimistic locking, lost updates can be detected, and it prevents the second update from erroneously replacing the data from the first user's update. So to illustrate this, let us use an example of how data in a movie booking scenario would look like under optimistic locking. So for instance, if Alan and Mark were to have read the data off the table, one after the other between a short span of time. And let's say Alan is the first who purchased the tickets to the seat. Assuming that a cinema flags the seat of a particular movie screening time in the tables column to have a better representation of the seat's availability. The seats is occupied column will be changed to true, and the database updates Alan's ticket purchase, and the version number increments with the update event as well. So when Mark attempts to check out his ticket purchase, the database would attempt to perform the same actions on the database records as with Alan, but this time round, since the version number does not tally, the database would know that another user, which was Alan in this case, have already secured the seat, and so Mark's update should not go through. If not, it would have erroneously overwritten Alan's update, which will result in a lost update. So both Microsoft SQL and MySQL databases have special columns that automates the work of changing the cell value of a record whenever it is updated. Microsoft SQL has row version type, and any columns defined with a row version data type are automatically updated whenever a row is modified by a user. MySQL has the traditional timestamp data type that can be flagged with an attribute of onUpdate current timestamp that allows the column to take the current timestamp value when the value of other columns in the record change. So next, Andrew will be going through with a short demo.
Thanks, Kunshen. So for this demo, we have prepared a small application called Optimistic Cinemas. So to simulate our demo, we're using two different browsers. So on the left hand side, we have Google Chrome, and this will be simulating Alan. And the right hand side, we have Firefox, will be simulating the customer Mark. So as mentioned by Kun Shen, the scenario that we're going to show is how optimistic locking will work in a movie booking site. So this is a movie booking site, and on the left hand side, Alan wishes to watch Beauty and the Beast at 1 p.m. and he goes ahead and checks the available seats at that timing and realizes that 3 available seats. And on the other hand, Mock is also interested in the same movie and at the same timing, and he too concurrently looks at the available seats, which are the same 3 seats that are available. And at this point of time, Mock actually decides to confirm his seat after selecting 10A. So when he goes ahead and confirms the seat, we actually have set up a particular breakpoint in our codes. So our codes that we have done is basically using the JPA, which is the Java Persistence API, as well as using a Hibernate framework. So using the Hibernate framework, we actually set up these annotations, and the main thing to take note is that for this particular model class, which is a seed class, we actually have annotated a specific variable called version, and we have added this version annotation to it, which you will see in the database later. So back to our demo, we have set the breakpoint to just before the transaction commits, and these are the lines of codes that actually have been carried out already. Just to briefly go through, so these 2 lines are changing the seed variable is occupied to true, and these few lines are actually decrementing the seats left column of the timing table. And we will go ahead and just let it run. And what you see in his screen is that his booking is actually confirmed. And when we go back to on Mock side, on the right hand side, we'll do the same thing. So he decides to choose the exact same seat, and because of the fact that both of them actually have read the data in a short period of time, the current list of seats that he have is actually not updated, when in fact it should be that 10A has already been booked by Alan itself. But nevertheless, Mock decides to go ahead and choose 10A and confirm his seat. So similarly, the breakpoint is actually hit at the same place, and what we notice is that currently in our database, when we look at the seat table, after Alan's has booked the particular seat, we notice that the version actually increased to 1, increment to 1, and the isOccupied variables have already been updated. So taking note that the version in the database is currently 1 of this particular seat number 10A, we look at the current code itself, and we take a look at this seat variable that is trying to save over here, update over here. We take a look closer into it and realize that the version is actually still stuck at 0, which is the initial version of the seat that Mock had actually read in the seat selection page, which is why when we let it continue, an exception will actually be thrown over here, which is the stale object state exception, and this exception means that row has actually already been modified and the version numbers actually do not tally to the database, and the respective error message will be printed accordingly. So this concludes our demo, and we'll be moving on to the requirements of optimistic locking.
Okay, so as the strategy of optimistic locking is to detect a change rather than to prevent collisions, optimistic locking is most suitable if collisions are infrequent. When there are lesser collisions, we can afford to make the change only when a collision happens. So for optimistic locking, it's most applicable to high volume systems and 3-tier architectures where you do not necessarily maintain a connection to the database for the session. So in such situation, the client cannot actually maintain database logs as the connections are taken from a pool, and you may not be using the same connection from time to time. In terms of the benefits, since the data will only be acted upon only if there are only if there is a previous change in the role, optimistic locking will be able to provide a faster speed as compared to other methods such as pessimistic locking and improve concurrency as it is assuming that there's no change to the data. Optimistic locking is used when you don't expect many collisions and hence this will cause lesser to do normal operations. But if let's say the collision does occur, then you may have to pay a higher price to resolve as the transaction will be aborted. In terms of the limitations, the main limitations of optimistic locking is that it cannot prevent application from selecting and attempting to modify the same data at the same time. So when two different processors modify data, the first one to commit the change succeeds and the other one will fail with an exception. Hence, this will require retry logic in updating the data and result in complicated update conditions to check if the data has been modified. As optimistic locking will require the application to roll back once there's a collision of data, having frequent collisions will result in more overheads required to change the same piece of data. And hence, using optimistic locking will not be wise in such scenario. So with that, we conclude our presentation.
Okay, so passing back to me, just to add on one point about the rolling back. So as you can see in our database, what we have done is after the exception has been thrown, the transaction actually rolled back, meaning that in this particular reserve seed method, all these lines of codes that will actually have already been run, because the transaction when it commits, it actually realizes version number does not match. All these lines of code actually have to be rolled back, which is what Shenxia has mentioned in the previous few slides. So with that, we've come to the end of our presentation. So thank you for taking your time to listen to our presentation. And yeah, these are references that we have referred to. Thank you.